So I'm going to be giving you one sticky note per group. So please hold on to the sticky note. Yeah. Who's this group? John and who's on the back group? Lachlan and Valentina. Is anyone else? Just you two. Okay. Okay. Pop your books away. Look up at the board. Last week, before we get started with today's lesson, there were two questions that came up last week that I would like us to explore further. First question was, someone asked, what is the diameter of Pluto? Now, we said Pluto was not a what? Yeah. Why? Well, it is a planet. What type of planet is it? A dwarf planet. Why was it considered a dwarf planet and no longer one of our usual planets? Yeah.
Because it's really small.
Right. So why we said it's too small, or it's small so it becomes a dwarf planet. So our question is, what is the diameter of Pluto? First thing I want you to do is, using your knowledge from last lesson and the diameters of all the other planets, I want you to predict, what do you think the diameter of Pluto would be? What were we measuring diameter in? What were the planets measured in? What was their diameter? Yep. Well, centimeters were for the circle. What are the actual planets' diameters measured in? Yeah, what were we measuring in? Not kilometres. So your prediction needs to be in kilometres, and you need to do a prediction with your partner. So you can have two predictions on one sticky note, right? So you have to predict how long you think the diameter is of Pluto, and think about the other planets. Who can remember what was the smallest planet in our solar system? What was our smallest one? Mercury. Can anyone remember roughly what was the diameter of Mercury in kilometres? 4,000. Okay, so if we know Mercury is 4,800 and we know Pluto is smaller than Mercury, then maybe we can use that as part of our prediction. So I want everyone to write down now, on the sticky note, what do you think the diameter of Pluto is in kilometres? And when you finish that, I want you to have a go at the next one. How often do you think all the planets are lined up in a perfect row? Yeah. Well, that's a good idea. You can add that there too. Yeah. Oh, sorry. Sticky note. So just all write your predictions on there. What do you reckon?
Wait, was it 3,000 something?
Okay, so you can write that down. You write down your prediction, and then Alex, you write down yours.
How big is Australia?
That's a great question.
The size of Pluto.
You think Australia?
Yeah, the same size as Pluto.
Is it?
Yeah. That's why.
So if Australia is like this, you're saying what, from here to here? Okay. Does anyone know? Okay, so if we're saying Pluto, you think is the same diameter, or is the same length as Australia, then does anyone know the width of Australia that could guide them in that? Look. I don't know. That's what someone said. Not sure. Write down your predictions.
800 kilometres.
1,000 kilometres. And where's your prediction, Chloe? What's that? Well, what do we reckon? What do you reckon the diameter is? 500 kilometres, okay. Is that you both agree on that, or you have a different idea? Well, you have a guess. You write your guess too. What do you reckon the diameter of Pluto is?
No, 3,000.
Okay. Right. What do we reckon? What do you think the diameter is, Katia, of Pluto? What's your guess?
I don't know. I have no idea.
Well, remember how we said Mercury was how much?
Was 4,000. I did 3,490.
Okay. So Katia, if Mercury is 4,000, is Pluto bigger or smaller than Mercury? So we know it's got to be less than?
Less than 4,000.
Okay, so pick a number that's smaller than that, but obviously it's still quite large. What's that?
I think it's every 3 years.
Okay, hands up if you have written your prediction. Hands up if you have not done your prediction yet. Okay, once you do your prediction for the diameter of Pluto, the next thing I want you to write down is, we know that the planets all orbit the sun, right? And do all planets travel at the same speed? No. Are they all the same size? No. So you can imagine as they're all doing laps around the sun, at some time they're going to come next to each other. Does everyone agree? At different times. Now sometimes maybe 2 might be together, sometimes 3 might be, sometimes. My question is, how often do you think it would happen where all 8 planets would be in a perfect line from the sun? How often do you think? Write it down on your sticky note. That's your second prediction.
I think it's like 300.
Well, don't cross off this one. He had a guess. Never. And
Or maybe 300.
how much is 5 decades? 50 years? You think 50 years?
I think like 4 to 6.
Okay. Look this way. Write your name on the sticky note. Then what I want you to do is use your Chromebook to actually research and find the answers. We've also got another question now. Our other question is, how far is it from the east coast of Australia to the west? And we'll see if it's similar to Pluto or not in diameter. So this is another question. And write down the answer on your sticky note when you find it out. Leon, what are you working on? What's the answer?
That was the answer.
Oh, pretty good.
The answer was 2009.
Excellent. Write down. Good. Did you find it? Oh, not bad. Good. What's that say? Hold on, but read this one. This says the 3 planets line up every 40 years, or 39.6 years.
So on average, the 8 planets, 396 billion years.
There you go. Were you close?
That's not even how old the Earth is.
Good question. What does that mean then?
That means they've never been aligned because Earth has never been aligned.
Oh, that's great. Awesome. What did you find out? How much was Pluto?
2,370.
Bigger than you thought or smaller than you thought?
Bigger.
Okay. Why did you find out? Did you find the diameter of the Earth? No, sorry, not the Earth. Diameter of Pluto?
I was like 100 up.
Okay, read that. What's it say?
36.6 years.
Yeah, for just 3 planets. Keep reading. How much for all of them?
Why is my mouse so glitchy?
That's okay. Did you find out the diameter of Pluto? What was it?
It's like 2,370 billion.
Good. Yeah, there you go. Were you close?
No. 390 billion years.
Has anyone found out how long it is from, or how far from the east to the west coast of Australia? And I want to see how similar it is to the diameter of Pluto. I'll come back. I'll just check this one. Yeah, what did you find out? Australia's approximately... Oh.
Almost 4. It's every...
Oh, that's northern to southerly point. And it's 4,000 wide from east to west. Okay, so it's...
It's like every 40 years.
Oh, is it? Keep reading. What's it say? The chance that Mars, Jupiter, Saturn, Uranus, and Neptune will all be... So on average, the 8 planets line up every...
396 billion years.
Yeah, do that.
Like West Coast.
Yeah, not east coast to east coast. Yeah, good. What was your question?
It's for this one. How wide is Australia? They've never been lined up basically.
Very good. So were you correct?
Almost. I said 300.
I thought you said never first. Yeah.
I said 300 million.
Good. Okay. Everyone, freeze. Close your Chromebook lids. Yeah.
It says here that Australia's twice the size.
Very good. Okay. Let's have a look at some of the things we discovered. Quick, screens down. Hands up if you can tell me what is the diameter of Pluto. Because that was one of the. Because we want to know why it's a dwarf planet. Part of the reason is its size. What is its diameter, Francesca?
2,376.6.
Say that again. 2,000.
2,376.
Yeah. Okay, now if you've got 0.6, what could we do with the 0.6? Because we don't need to know exactly, what could we do with the 0.6?
Like take it away and just add the zero.
Instead of, yeah, you could take it away, or what could you do with the 0.6 before you get rid of it?
Round it.
Round it. Now if it's 0.6, would I round up or down? Up. So let's do, just for purposes of this, 2,000 kilometres, right? Did anyone find out the diameter of, or not diameter, sorry, the distance from the east to the west of Australia? Aaron, did you find that? 4,000 kilometres, very good. Almost around. Okay, so who can tell me roughly what's the comparison between Pluto and the width of Australia? What would you say?
I have that on my screen.
Yeah.
2,300 something.
Yeah, but what's the relationship between the two? We've got 2,300, 4,000 roughly.
It's like almost double.
Yeah, almost double, very good. So we could say that Pluto is a little bit more or close to double the length of Australia or the width of Australia. Or half of it, very good, yes.
You could almost cover Pluto with Australia.
Yes, you could, yeah, exactly. Like the,
Fit Pluto on
yeah, Australia is like double the length that way. You could fit 2 Plutos. So I could draw 2 Plutos. If I'm drawing the scale, I could almost draw one here and another one there across it. Now, the very interesting one, last week I heard a couple of people, even in the other class, were talking about how often the planets would line up. Hands up if you can tell me your prediction. Don't tell me the answer, just a couple of predictions. What did you think?
Every 20.
Every 20 years? 4 to 6 years?
Every 10,000.
Every 10,000?
3.
So every 3 years? Katia?
Every 10.
Every 10? 15 to 20?
100 million.
300. Well, what is the actual answer? How many years would it take for the planets to roughly all align? Valentina?
396 billion.
Years. 396 billion years. Now, John made a really good point. How old is the Earth? Or how old is our Earth? Now, if it only happens once every 396 billion years and the Earth's roughly 4 billion years old, what does that tell us about when the planets have aligned, or what can we predict?
Well, it's only been line once.
You think maybe it's only been aligned once, or maybe never it's been aligned? Yes, so that's really interesting. But what you might have found out was that maybe 2 or 3 planets may align every 40 years or 20 years. So sometimes 2 or 3 can align, but for all 8 to ever be in line, it's almost, yeah, in statistics, when we say chance, how would you describe the chance of it happening? Is it certain, likely? What would you describe it as?
Near impossible.
Yeah, nearly impossible.
Very
Highly
highly unlikely.
unlikely.
I would say really impossible because NASA says that the sun might explode in 7 to 8 billion years.
There you go, yeah, excellent. All right, what I want us to do, we're going to jump over this for a moment. I have a little piece of paper. I want you to read with your partner the learning intention and success criteria, and then we're going to talk about it together. So quickly read it to each other. Okay. Sorry? I'll give you 2. I know there's a group of 3, but just... Do you want to grab a...
Just give it to me.
sorry, I thought if you want to read one. That's right, all good, that's it, yeah. But do you want to keep one? Do you want to read one?
No.
Oh, you take one? No? Okay. Yeah, you take one. There you go one, yeah. Okay, sorry. Everyone look up, my fault. Sorry, this one's slightly different. I've accidentally printed the wrong one, I think. Sorry, have a look at the board. Sorry, ignore that one. Look at the board. Can I have someone read the board? Lachlan.
We are learning to use ratios so we can model side and distance of planets.
Hands up if you've heard of the word ratio before. Can someone tell me where they've seen or heard of a ratio, or what a ratio might be? Anyone got any ideas? Yeah, what do you think? Let's just have a...
Sounds it's kind of similar to the radius, but
Yeah, similar to radius. Yeah? Yeah, what do you think?
some sort of measuring tool.
Okay. We're going to have a look at that today. We'll discover, yeah? What do you think?
Well, like if you measure how heavy 2 things are, and one's like 4 times as heavy as the other one, it's 4 to 1.
Fantastic. All right, so that's an example of a ratio. So for example, something Like one bucket might weigh the same as, so 1B, one bucket might be the same as 4 litres, or it could be 4 of something else. So that's an example of ratio. We're going to have a look at some in a moment. For today, I want you to investigate different methods for calculating ratios. So last week you did an awesome job of trying to calculate different ways of measuring a circle. Today I want you to try and measure or discover different ways of calculating a ratio. You can explain why we use ratios when working with planets, and you're going to use mathematical evidence to support your predictions. All right, we're going to have a look at this in a moment. So these were our planets from last week. They were the order. Who can tell me what was the smallest one? What was this one here? Yep. We have Mercury. Now, 4 millimeters was how long the circle, or the diameter of the actual paper circle, and 4,879 kilometers is the diameter of the actual planet, right? What was after Mercury? What was 5 millimeters or 6,792 kilometers? Valentina? What was the second smallest? Mars. So Mars is actually second smallest. Then we had at 12,104 kilometers, or it was 10 millimeters on paper. John, it was?
Venus.
This was Venus. And then almost identical in size, just slightly bigger, 12,756 kilometers was?
Isn't that Neptune?
Nope, not Neptune. What else could it be? Almost the exact same size as Venus. Earth, very good. So this is Earth. Then we had 49,000 kilometers. This was, Aaron?
Uranus?
Or? Yeah, so Neptune first. Neptune smaller. What came after Neptune? Uranus. And then the second largest, Esther? Saturn, very good. And at 142,000 kilometers was, Francesca? Jupiter, very good. Now this is the order. Now there's two numbers. What is the number on top? What is that measurement? The millimeters. Yes?
No, isn't that of the circle?
Yes, of the paper circle. What is the number below the millimeters? What is that number, Chloe?
The distance.
It's the diameter of what? The actual... Yeah, the actual planet. Now we've got two numbers. All right? I want you to talk to your partner and tell me, why are we using circles, paper circles, to represent the real life planets? Talk to each other. Okay, why are we using it? I've printed the wrong one. I just realised. I went there. I'm like,
Can I contact
yeah. Okay, hands up. Who can tell me why are we using paper circles to represent the planets? Why are we using these to represent actual planets? Yeah.
Because we can't just grab them out of space and bring them into the classroom.
Yes, very good. Why else?
It's easier to measure.
Easier to measure. Fantastic. Yep.
And most planets roughly circle or sphere
Yeah.
shape.
So we can use a circle to represent it. Good. Yep. Why else?
Say for instance, Mercury, the millimeters are closer to that, the
Yeah.
actual kilometers, and if we make the actual model a little bigger than the Earth.
Exactly right. So have a look at this page here. Because they're represented as circles, I can actually see how much bigger or smaller one planet is just by looking at them. I couldn't do that if I was looking up in space. It would be very hard to tell. But because I've got circles to represent it, I can quickly tell in comparison how much bigger they are from each other. Can everyone see that? Right, so what we're going to do today, I want to create a key, or I want you to create a key. Now let me give you an example of a key. Has everyone seen this? What is this before? What is this? What is it? It does have a key on it. What is it? Yeah? Yeah, what type of graph is it, Elsie? Very good. This is a pictograph. This is a key. What do we have at the bottom? What's the key telling us, Katia?
Saying that one whole pizza represents 4 children.
Fantastic. So if we have a look at the barbecue chicken, how many kids actually like barbecue chicken? Yes. 5 kids? Yeah. So one pizza equals how much? 4. And then a quarter would be 1, right? We need to develop a key like this for our planets because we're measuring with millimeters, but what I want to know is how many millimeters actually represent kilometers in the planets. That's what we want to try to figure out. Let me give you another one. Has anyone seen this before? This is like similar to a ratio. It's like another key. It's telling us that 1 kilogram is the same as, right? Here's another one. And has anyone seen this maybe in baking or when you do cooking? Who can explain what this is telling us? Francesca?
Like how much flour or whatever is in how much product is in there.
Yeah, Valentina? Yeah, so if this is a recipe and I'm making dough, if I add 4 cups of flour to make it a dough, how much water do I have to add? 1 cup. What happens if I added 8 cups of flour? How many cups of water would I need? 2. What happens if I had 12 cups of flour? How many cups of water would I need? 4 cups of flour is 1 cup of water. 8 cups of flour is 2 cups of water. 12 cups of flour would be 3. Very good. So this is what we are using. I want you to design one for the planets today. So I want you to tell me, with your partner, what is the purpose of a key and how would you define a key? Talk to your partner now. Not yet. No, just talk to each other.
It's just easier so you know, like, if you just saw that thing without it, like the pink thing without the key, it wouldn't
What do you think you'll have to do?
I'm trying to find what 1 meter is in like kilometers.
Fantastic. What do you think, Ivana, tell me, what do you think you have to do? Yeah, you measured them last week. Yeah, figure out what?
See how much they equal and see which has the most in common.
Okay, what about the millimeters? We want to work out if, say, Mercury is 4 millimeters, but it equals 4,800 kilometers. We're trying to work out how much 1 millimeter would equal in distance. Like if 4 millimeters equals 4,800, how much would 2 millimeters equal? How much would 1 millimeter equal? All right. What do we have to do?
Okay, it helps you understanding what the numbers are, because in the picture graph,
Yeah.
with the cheese, you would think that's 3.
That's right. Yeah.
But it's really 15.
So
because
how could you make a key for the planets? How can we make a key for the planets? Like when we're measuring on paper, what are we measuring in?
Millimeters and centimeters.
Yeah, and what do the millimeters actually represent in real life?
Kilometers.
Your kilometers. So we need to work out as a key, 1 millimeter is the same as what? What does 1 millimeter, you got to tell me, what does 1 millimeter represent in kilometers?
1,000.
Well, I don't know. That's what you're going to work out. Okay? Do we know what we have to do?
No.
So what are we measuring the circles in?
I don't understand how you do that.
Can I get a cup of water from the office?
No, yeah, answer.
I don't understand how to do a key.
So that's what you're going to try and work out a key. Because at the moment, Mercury was about 4 millimeters, right?
Yeah.
How much was it in real life? How many kilometers was it? Mercury, 4,000.
4,800.
So what I want you to tell me, see this ruler here, I want you to tell me, there's a millimeter there, well that's 10 millimeters, what do 10 millimeters represent in real life?
1.
In kilometers? 1 kilometer?
1,000.
1,000 kilometers? But what does it represent in the planets? That's what we're going to work out. That's what we need to try to work out. Okay, everyone stop, look up. So with these planets, we have these planets here, look up. We know this planet here, Venus, Venus is what's the diameter of Venus? Call it out. 12,104. Right, but on the piece of paper, how many millimeters was it? 10. So we need to create a key so I know, and we all know, how much 1 millimeter would actually equal in kilometers. That's what I want you to try to figure out. Now, I've got some questions to help you. We're going to walk around the room, and on the butcher paper, you can find a butcher paper with your partner, grab some texters. So I've got a piece of paper over here. There's a couple at the back and one over here. If two groups want to work on the same paper, that's fine. Just make sure you split half-half. So for example, Esther and Alex might work here, and then Leon and Michaela might work on this side. I want you to try and work out or create a key for me or a ratio that explains how much 1 millimeter equals in the planets. So we said that 4 millimeters equals 4,879 kilometers. I want you to tell me what 1 millimeter would equal. So pick just one planet, look at the diameter of the planet in real life and how many millimeters it was. All the numbers are on the board, and then try and find a way to work it out. I haven't told you, I just want you to have a go. Try and measure, try to figure it out for yourself, okay? Let's go find a paper and some texters.
At the end of this lesson, we know how much millimeters mercury will be, right?
Well, we already know this one. So mercury on the paper was 4 millimeters, and in real life it's 4,879. I want you to tell me, what does 1 millimeter equal in kilometers? Okay, let's try. Yeah, it's a fun one. Let's go. So how are you going to work it out? Try and work it out. What could you do? So pick a planet. Which planet are you going to do? Okay, good. Write down what its diameter is and how many millimeters it was. Which planet are you going to do? Pick a planet. Which one? Which circle? What numbers are you going to use?
I already did the calculation.
Okay, which one?
1 millimeter.
Yeah, is what?
It's roughly 1.2 kilometers.
How did you work that out?
Because it says 4 millimeters, then it's 4.879.
Excellent. Write down here. Show me exactly what you did. First thing.
Equals what? 1.1 kilometers.
1.2.
Excellent. Well done. Go get a texter as well and write down how you figured it out. Explain it to me. Yeah.
Doesn't 100,000 millimeters equal 1 kilometer?
In real life, yes, but we're drawing these little circles we've made up our own measurement system here. So what I want you to tell me is like millimeters. There's 4 millimeters for mercury in the little circle, but in real life that equals 4,879. So what would 1 little millimeter be if I did another planet? If a planet was 1 millimeter on paper, how big would it be in real life? Okay, try and use any measure you can. Can you move over from this? Don't touch your one. Okay, so what do you think? How are you going to work it out? Pick a planet first. Pick a planet and pick two measurements.
Jupiter.
Okay, so Jupiter, how many millimeters is Jupiter? 12. And how many kilometers is it in real life?
142,900.
Okay, so if you had to make a key, what could you turn the key? So at the moment, you'd say 112 equals 142,000. How could we make that smaller? What could we do for 1 millimeter? Or what could we turn that into?
1 millimeter equals 12.
No, because this one, we don't know what that equals. So 112 millimeters equals 142,000 kilometers. What could it be?
So like 1 millimeter.
That's one when you try to work out on the paper, okay? Write that down and try to work it out. All right, what do we reckon so far?
We've got the 1 millimeter.
So you reckon 1 millimeter equals 1,219? Oh, very good. Excellent, okay, good. So now can you write what mercury, so do it as a ratio. So write mercury at 1 millimeter like that. 1 millimeter equals, or is the same as that. Then do another planet and see if it's the same or different. Yeah.
Can we go to a calculator?
Mercury at 1.
Because that's apparently how much 1 millimeter is.
Is that 1 millimeter? How do you know that's 1 millimeter?
He did some minus.
He did what?
He did minus.
Minus? Would you minus to get...
He minus the kilometer?
How would you get it? How would you know what 1 millimeter equals? What could you do? What happens if we did this? If 10, can you write, see Venus?
Yeah.
10, oh, let's do the first one, Mercury. Can you write 4 millimeters equals? Equals, what's it equal? 4,879. Can you draw that? Are you subtracting, are you?
I don't know.
What's another way we could do it? How could we work out what 1 millimeter is? Yeah, okay, good. So if 4 millimeters equals that, what would 2 millimeters equal?
Half that.
Okay, so let's try that. So 2 millimeters would equal?
Half would be.
It's 11. Wait a second.
It's half 7.9.
Just do it roughly, it doesn't have to be exact. What could it roughly be?
Isn't it half 7.35?
Yeah.
Gotta go that and that. Do you know that Aaron is 116 centimeters tall? Oh, geez, he's 10 years old.
And half of that? That's half. Okay, let's stay with that. Okay, good. So 2 millimeters equals that. So what could you do next?
1 millimeter.
Okay, excellent. Good, excellent. Well done. There you go. That's it. Yeah. Do the number in there.
Yeah, just make it small. Just write it here.
Wait, is the big number going in? Yeah, and you're putting the big number in there, are you? Yeah. Why don't you use a Cartier? Why don't you get a calculator and do it and see what that equals? Yeah, check. Okay. If that's too big to work out, why don't you use a calculator and see what it equals?
Yeah.
Okay. Or could you round that to a number? Like what's 112 round to an easier number?
110.
Okay, let's round to 110. So write 110 here.
112.
And then equals.
That's all.
Yeah, and what would that round that to the nearest one? 100 and well, what's an easier number? 100 and, could you round down 140?
Yeah.
That's easier. Okay. So what could we do instead of 110? What could we cut that? Could we cut that into a smaller number? What could you cut that into?
Maybe 100.
Yeah. Could you cut it in half?
Yeah.
Yeah. What would it be in half?
55.
Okay. So we're at 55 underneath. So 55 equals. So 55 millimeters would equal. What's half of that one?
It has a decimal to it.
That's good. Just round it.
That equals 70.
Yeah. Okay. Good. Now, could we try around that? Oh, cut that in half again. Keep going.
That equals
Do it roughly. It doesn't have to be exact.
22.5.
Okay. What could we round that to?
22.
Okay. Let's do that. 22 equals.
That's not it. That's not
35.
Okay. Good. Can you keep going until you can get to like 1 millimeter? At the moment, you've got 22 millimeters equals 35. Maybe you could round that to 20 mils equals. Keep going until you can get to 1.
answer.
Did you get another one? Did you get another planet? Have you done another one? So Mercury was how much? 1012. Venus was that? Okay, what do I want you three to do now that you've got 3 planets? What do I want you to do? Once you get these 3,
They're not even, so they're not accurate.
yeah, so what can we do to make them accurate?
Round them.
Can I get you to do this? See how we've got all these numbers? I want to end up with one number. Can you average them? Do you remember how to average from heart rate lesson? Can you average them all? So add them all together and divide them and see what you get and see how close. All right, what do we get? Do we find our number?
5.
Yeah, okay, keep going. Yeah. John, what did you get? What do you reckon? Okay, so how'd you get 6,000? Oh, is that another planet, are you? Could you divide that by that to see how many 5 millimeters are in 6,792? Use a calculator, see what you get. Try that. Or you could keep going in half, like the way you're doing. Okay, can I have everyone stop? I want everyone to stand up. And what I want us to quickly do is walk around the room and have a look at some of the different calculations people have done and see what their key is. What have they got 1 millimeter to equal? Okay, let's go around the room, have a look. Look at someone else's paper, read their paper. What did you get? Did you get to 1, did it? 4, hold on. Wait, how did they get to 17? Wasn't that 10 equals 17? Because you cut that one in half, but you didn't cut this in half. So that should be 10 is 17.
So well done.
Yeah,
No, we haven't
have a look. Check theirs. Yeah. Go and have a look at someone else's. Aaron, go have a look at another one. What did they do?
What's going on here?
What was their key? Okay, can I have everyone stop and come back to their desk quickly? Okay. All right. I'm coming around with a little piece of paper. On the piece of paper, we're going to look at some different ways that we could calculate what a millimetre is. Now, the reason why we want 1 millimetre is because we want to be able to draw other planets, other moons, but we can't draw them unless we know what 1 millimetre equals or how many thousand kilometres there are. So, First thing I want everyone to do, on the piece of paper, who can read to me what it says on the piece of paper? Valentina, what's it say? Okay, we're going to try, this is called a ratio table. Can everyone say ratio table?
Ratio table.
So the first thing we're going to do is we're going to pick the planet Venus and we're going to write the diameter of the circle of Venus. So what was the diameter of Venus on the board? What's it equal?
10.
So can everyone write 10 millimeters in their table in the first one? So 10 millimeters under circle.
Wait, here.
Under circle. How many kilometers was Venus, Aidan? So can everyone write 12,104 in that box? Kilometers, thank you. Yeah. Now this at the moment is already a ratio. This tells us that every 10 millimeters equals 12,104 kilometers. Right. So what happens if I do this? Can everyone write 20 mils? What would 20 millimeters equal? Write it in your box. If 10 millimeters equals 12,000, what would 20 millimeters equal? Yeah, okay, yeah, so double. What would you do? Welcome, come sit down. Who can tell me what would, if 10 millimeters equaled 12,104 kilometers, what would 20 mils? How did I get from 10 to 20? Who can tell me? How did I get from 10 to 20? Alex? I added 10 or I? Not subtract, what was it? Doubled it. So 12,000, if I double, what would I get? Luca? 24,208. Very good. All right, instead of doubling 10 millimeters, what could I do instead? Let's halve it. What's half of 10 millimeters? And can you halve the 12,000 and see what you get? So if 10 millimeters equals 12,000 kilometers, what would 5 millimeters be?
No idea.
What are you meant to do?
I had no idea.
What are we doing? Katya? What are we doing?
We have to, from 5 millimeters here, we have to see what the plug diameter is.
Yeah, so if 10 becomes 5, I halve it, then you need to halve the 12 as well. Try.
This number?
Yeah. Yep.
Would we half it? Mars is 5 millimeters.
Yes.
But that won't be the same as what half of.
Awesome. Very good. Let's have a look at that. Let's check. So, who's worked out what 5 millimeters is in our ratio? Michaela? Close. Try again. 6,000. Yep, you're right. 6,052 kilometers. Very good. Now, Aidan's made a really good point. On our ratio, we said that 5 millimeters, according to Venus, everyone write Venus at the top of your page. We said Venus, 5 millimeters equals 6,000 kilometers. But let's actually look at Mars. According to Mars, they said 5 millimeters is the same as how many kilometers? What did they say, John?
6,792.
Very good. So this means that our Mars circles are using a different ratio. They're very similar, but that we're using different ratios for each planet. Instead, now what we're going to do is, if I've got, instead of 5, instead of 10, I can change 10 into 1 millimeter. Can I write 1 millimeter? So if to get rid of 10, what did I do? I just crossed off the 0. Can we do the same number but just cross off the last number and see what we get? What would it equal? What would 1 millimeter equal? Just wait, we'll let everyone have a go. So cross off the last number and we'll see what would 1 millimeter equal in kilometers. Excellent. We'll have a look at what you got in a moment. We'll see. So did everyone cross off the last number? Katia, did you cross off the last number? So what did it equal, Katia?
12
Well, it won't be 12 now, but 1, 2, yeah.
104. No, 1 R.
Okay, who can read me what that number is? What number actually say?
1,210 kilometers.
Very good. So that is our ratio. Our ratio, if we had a key on our piece of paper, we would write that 1 millimeter equals 1,210. All right, can we try? Can everyone stand up and we'll go look over this page? Everyone stand up, come over here. Just come back a little bit, explain what you did, and then we'll have a look at another group. Take a step back, Quick. Shh. Lachlan, jump out of the way. Does your group want to explain how? So you got almost the same key or ratio. What did you get?
For Venus, we got 1,210.40.
Good. Explain how you did it. Shh, boys.
So we did 12,104.
Yep.
Divided by 10.
Yes.
And we got 1,210 with 4 remainders. So we did the 4 over 10, and then we put that into a decimal, which was 40.
Very good. Excellent. Can we go to the back paper over there, Ivana's group? Be careful in the middle of the room. Katia, watch out where you're walking. Watch out. Okay. Can someone, Ivana, do you want to show us what you tried at the top for mercury?
Mercury, and what I did was I kept halving it. So I started off with 4 millimeters, and then 4 millimeters was 4,879
79 what?
kilometers.
Yeah, okay.
And then I halved it into 2 millimeters, and then I halved 4,879, and then I halved 2 millimeters one more time to get the answer.
So what did your end result? You said 1 millimeter was equal to?
1,207.
So Ivana did Mercury. Was Mercury close to Venus in its ratio? Do we get a similar? So we said Venus was 1,210, yeah, and Aidan, this was? Only 7 off, 1,217, very good. Luca, do you want to explain what you were starting down there? You had 5 millimeters. Which one were you doing? Was that Mars?
I think that was Mars.
Yeah, okay. So what were you doing? Similar thing?
Yeah, so I kept on halving.
Okay.
I didn't quite
Finish. Okay. Good. Excellent. What was the idea? Some people were trying to subtract. What were we trying to subtract? What was the idea there? Who was subtracting? Elsie, were you trying subtraction or?
Yeah.
What were you trying to work out by subtracting?
I'm not sure.
Okay, it was just something you tried?
I tried subtraction.
Yeah, what did you subtract?
I'm not sure. John started doing it.
John, what was your idea with subtraction?
which this did not work out, but subtract the millimeters from the kilometers.
Yeah, and it didn't work.
No.
Excellent, very good. Can we go have a look over at Leon's side? Leon, do you want to explain? You got almost the exact same. You got 1.2 kilometers for your ratio. Do you want to explain how you got 1.2? What did you do?
Well, I got from the Mercury, and because it said 4.8,
Yeah.
and if you divide that by 4, you get 1.2.
Very good. What I want everyone to do now is when you go back to your desk, I'm going to give you your black sheet. On your black sheet, you need to write a key. Now, you can do it your choice of key. It could be 1 millimeter equals 1.2. It could be 1 millimeter equals 1,217. It could be 1 millimeter equals 1,210, or it could be what one you found. But it should be similar. We should be close. Or you could do the average if you want to work out the average, okay? I'm going to get you a piece of paper and you need to write a key. So you're going to write 1 millimeter equals, tell me how many kilometers on your sheet, okay? I'm going to come and give you your sheets. So John, come and grab your sheet. So you need to write it on there, or you might cut a piece of paper and stick it on to write it, Alex. So you need to make up a key and write it on there. Leon, Esther, come write your key on there. Katia, Aaron, make up your key, write your key on there. Chloe, Ivana, and Lachlan. So you need to write a key at the top. So what is your key? 1 millimeter equals what? So what does 1 millimeter equal in real planets according to our piece of paper? 1 millimeter represents what? Quick, pick a key, write it on your piece of paper, write it on here. So you need to write your key on here, somewhere we can see it. Got it? Yes.
You know how we were looking at the average?
Yeah. Yeah.
Do we write the average as the key?
The average as the key? Yes. So whatever the average is, you'll write 1 millimeter equals whatever the average was.
Wait, so we wrote 1 millimeter.
Well, did you do the average? So how many do you have?
I've only got 6. I have
Yeah, just
to
do 6. You don't
seven.
no, don't do all of them. Just do the average of those ones.
Oh, okay.
Right, otherwise, it'll take way too long. And then divide it by how many you have. Okay. Okay. Hands up if you have drawn your key. Have you written your millimeters equals on your paper? Michaela, have you written yours? Okay. What I want us to do. Now that we have our key, we can work out how big we're going to draw Pluto on our piece of paper. All right? So can I have everyone come to the floor? Quick, come to the floor. Okay. What did we say 1 millimeter equaled? How much? Yep.
1,210, but round it to 1,200.
Yeah, it does. You can do that. That's fine. Pluto. The diameter of Pluto was. Who remembers how much Pluto was?
2,736.
Okay. Right. Now, to draw Pluto on our page, we don't know how many millimeters Pluto actually is on our page. So to actually work it out, this is when we use our key. So all we have to do is, if you get a calculator and you write 2,736 divided by the key, what was our key? 1,210. Whatever the answer is, that will tell us how many millimeters Pluto is. And you're going to make it out of paper and draw it on your paper, on your black paper. So remember, Mars was 5 millimeters. Mercury was how many millimeters? 4. We're going to work out how many millimeters Pluto will be, and then you can draw it. If you've done that, then you can pick another planet. You could pick another moon. You could do Earth's moon. Find out the diameter and divide it by 1,000, or whatever your key is, 1,200, and that will tell you how many millimeters it is, and you can actually draw it on your paper. Yes?
You know how you said the kilometers of Pluto is 2,736?
Yeah.
I thought it was 2,000.
Oh, 300, wasn't it? 2,376? Okay.
Yes.
So, can everyone, we're going to go back to our desk, we're going to divide 2,376 by whatever your key is. Yours might be 1,200, I did 1,210. Whatever the answer is, that will tell us how many millimeters it is. And then I want you to draw Pluto in that many millimeters on your page. If you finish Pluto, then you can pick Earth's moon, you can find another moon from Jupiter, research how much the diameter is, divide it, and you can draw it. Okay, let's go draw it on our, what was your key? Come show me.
It's around 2. Because I wrote
Around 2?
Out of these 6 planets, the average of 1 millimeter,
Yeah, was?
is 1,264.46 kilometers.
Okay, and we round that up or down?
Down.
Good, so let's just do 1,264. Good, go write that on your poster. 1 millimeter equals 1,264,000 kilometers. Good work.
Out of the top 4.
Good job.
get
Okay,
a calculator.
go get your Chromebook. Use your Chromebook to divide, or you can use a calculator. Sorry?
Where do you write it down?
You just got to work it out and then draw it on your paper.
But bike? Or...
Yeah, on the bike. No, you can't. No, use your Chromebook. So, what did it equal?
Look at the secret, ready? 2 millimeters.
Okay, awesome.
Around.
Awesome.
Just rounded it.
Good. So let's put Pluto somewhere on our page. That's 2 millimeters. Get a ruler and draw it. That's it. Divide by 2. But did you get millimeters 2000? Did you? Was that your key? What was your key?
What do you mean our key?
Where's your key? Here. 1000.
210.
Okay, so divide Pluto by 1210. No, other way around. So do Pluto divided by that. And then draw what size it would be. Did you make it? How small is it? Where is it?
And it's actually perfect.
Is it? Awesome. Well done. Now look up the Earth's moon and find out how the diameter of the moon and divide again and see how big it is.
Wait, moon or Earth?
Earth's moon. The moon, our moon.
Wait, what is moon again? I forgot. No, what
Our
is
moon. The moon in the sky. Our moon.
Oh, wait, what is it?
What? Yeah, do it on Coco. So 236 divided by 1210 and see what it equals. Did you work it out? Did you divide it? What's it equal? Exactly. So it's 1 millimeter, 0.96. What can we round that to? 2 millimeters. Yeah. So it's roughly 2 millimeters. So let's draw Pluto on your page with 2 millimeters. Where's yours? Yeah, draw it on there. Hands up if you can tell me what does it equal. What is 2376 divided by 1210 or your key? What did it roughly equal? 1 point.
It's like 9.
Yeah, okay, so what's 1.9? What would we do to 1.9? We could round it up to 2. So if you drew Pluto, Katia, on your paper, Pluto would be how many millimeters in diameter? Only 2 millimeters. Can we draw that on our black paper? 2 millimeters. Okay. All right, what I want you guys to do is, I want you to predict how many millimeters would the sun be. Hands up if you've drawn Pluto on your page.
The sun would be the biggest, so maybe.
Okay, everyone stop. Shh. Look this way. Shh. Look this way. Eyes on me. Thank you. Once you have drawn Pluto, Aaron, you're going to get a texter, Lachlan. You're going to come up to this page and you're going to predict how many millimeters would the sun be if you drew the sun on the paper. So if Pluto's only 2 millimeters and Jupiter's about 112 millimeters on paper, how many millimeters would the sun be if you drew it on the paper? Come write your name and how many millimeters it is. Only if you've drawn Pluto. Did you draw Pluto? Draw Pluto and then do it. Write a prediction. Get a texter. Quickly write your prediction on the board. Have we divided? Have you done your division yet of Pluto?
I've done my Pluto.
Where is it? Equals what?
It's 1.
1. Did you divide by? No, other way around. 2008 divide by 1002. Did you draw? Quick, have you done it? Did you draw Pluto on your black paper? What don't you understand?
I don't understand what to do.
Yeah, ask me another question. What do you mean?
I don't know what to do.
Yeah, what part? What part don't you understand?
What she's doing right now.
So did you divide? It's on the board, 2000.
That's divide that exact number.
Yeah.
Oh, okay.
Okay, right, how many millimeters do you think it is? Quick, write how many millimeters. Then, on your Chromebook, I want you to look up the diameter of the sun. Find out how much the actual diameter is.
No, in millimeters?
No, just actual.
What is...
And don't say it. Just write it on your sticky note.
So
How many millimetres do you think?
so if Jupiter is like 100.
And 13 millimetres, or 112. Yeah, don't say it. Did you write your prediction? Who has not done their prediction on the back? Come on, go do your prediction quickly. Have you done Pluto sun prediction on the back? Yeah. Yeah. What did it equal? So what's this number? What's 1.9? That's
A number.
yeah. What's the number mean?
The diameter
Yeah, diameter of.
of Pluto.
Yeah, in millimetres. That's how many millimetres Pluto would be. You go draw that 1.9 millimetres. So grab your ruler and draw it on the black piece of paper. Where's 1.9 millimetres? So that's 10 millimetres. Where's 1.9 millimetres? Where's 1 millimetre? Is that 1? Is that 1?
Yes.
No, that's 10. That's 9. That's 8. Where's 1?
Here. No. Here.
There you go. Yeah. So I want you. Yeah. So I want you to try draw Pluto. That's how big Pluto would be on paper. All right. That's why you try to draw.
So then what do you have to put on the back?
Predict how big do you think the sun's diameter is in millimetres?
I put 548.
Okay. Hands up if you have written your prediction on the back. All right. I want everyone to go, once you've done your prediction, look up the diameter of the sun, and then I want you to divide it by that to find out how many millimetres it is. Go. Check it. Yeah. That's it. Okay. Shh. Turn this way. Eyes on me. Hands up if you can tell me, did you look up how many kilometres is the diameter of the sun? Look it up on your Chromebook. What was the answer? Look up. 1.4 million kilometres. That's the diameter of the sun. Now, to work out how many millimetres it is on paper, we need to divide it by 1,210. Can everyone do that? So on your Chromebook, do 1.3 million divided by 1,210. And that will tell us how many millimetres. Hello, Tips again. Yep. Okay, will do. Yep. Thank you. Okay. Did anyone divide? What did it equal? How many millimetres? If we drew it in millimetres, how many millimetres, Lachlan? Now, this is in millimetres, right? How will we turn this into centimetres? What would that be in centimetres? Yeah. Yeah, let's do 151. Oh, hold on. Yeah, 116 centimetres. Everyone come to the floor, quick. In a circle, please. On the floor.
That's like almost 4 rulers.
Now, how many centimetres is a ruler?
30.
Oh, 30. Sorry, I thought you meant, yeah, good. Move back so there's room. I'll just be another 5 minutes. I'm just packing them up and we'll get done. Sorry. Okay, let's have a look. So, we want to make, we said Pluto was 2 millimetres on our key or in our paper model. Now we're going to make a model version of the sun to go with our Jupiter. Now remember, Jupiter was our biggest circle. It was about that big. It was 112. We want to mark out 115 centimetres. Now this ruler is how many centimetres?
200.
No?
1 metre.
It's 1 metre, which is how many centimetres?
100.
100. All right, so let's check this. So we'll start from that side. We'll get a texter and we'll see first. We'll see if it fits. So we'll put this here just on the edge. All right, hold that there. Right. How many more centimetres do we need to add?
16 there.
16. So let's go from 16 from here.
Actually, it might.
Turn it that way.
I'm 10 minutes.
It might just.
Okay.
Yeah.
Cool. All right, 16. And now we have to do it the other way. So this is our middle. So we'll go do half of 116. So it's almost 6.
Half 116 is 58.
Yeah, perfect. So there's our middle. Right now, I've got to measure the other way. So you hold there, Michaela, hold that still. So there's 100. Do you reckon we'll fit the other end as well?
Yes.
All right, let's try add 15 from here. Oh, 16, sorry. Okay, cool. All right. Now we're going to try draw a big circle as even as we can. This is going to be very hard. Let's just try it. So if we use the paper, then this is basically the size of the sun compared to all the other planets. This is the size of the sun if we're using the same ratio, remember? This is just, that's a very wonky sun. This is, exactly, if you had to draw the sun and stick on your paper, that looks a bit like an egg, but that would be the size of the sun compared to Jupiter. How huge is it?
That's big.
That's massive.
That's a big boy.
So why do you think then all the other planets orbit around the sun? Why would it orbit around the sun then?
Doesn't it give them energy?
It does give energy. It has
Because
light.
because it's so big, it has a higher gravitational pull.
Yeah, so all the other planets orbit around the sun because of its mass. It is that huge, and its weight is so, and the gravitational pull is so big that all the other planets revolve around the sun. Yeah.
But wouldn't its gravitational force, wouldn't it just explode?
What would?
It has-
The sun?
Yeah, because the gravitational force could.
Well, that's almost like a black hole. A black hole does that, and that is like when a star dies, like a sun. So when a star does die, yeah, like implodes and makes black holes. But that's as it dies. So this would be the size of our sun compared to all our other little ones. So if we now put Pluto, how many millimeters did we say Pluto would be roughly? 2 millimeters. So if I put 2 millimeters in the middle,
2 millimeters next to...
this is even too big. Pluto would be like a speck. And the Earth, remember that we said the Earth is about 1 centimetre. So the Earth would be roughly that. That's our size compared to the sun. Right? It's really, really tiny.
We are in that dot somewhere.
Yeah. Right.
We're in the sun.
What I want everyone to do, can I have everyone go and put your sheets back in its pocket, put all your Chromebooks away, and you need your Chromebooks and line up at the door, please, carefully.
3 million Earths can fit into the sun.
Yeah, there you go.
So maybe
Yeah.
if you draw like 3 million of those, it could actually
Fit in there, yeah. There you go. The largest star. There's a star's even bigger, yeah.
It's like Pluto, Earth against our sun.
That's right, again. It's like going around in circles. Also, your little predictions, listen, shh, all your sticky notes and your ratio tables need to go in the plastic pockets. Put them all in there. I'll find out. All this, sticky notes, table, all go in. Are they all in there?
Oh, wait.
Put all your stuff in there first. Right there. Put it on my chair. Sorry, what do they need to bring? Just Chromebook? Chromebook? What do they need? Chromebooks? Okay, you need holes, your reading book and Chromebook, and line up at the door. All your sheets and pockets need to be on the chair. All your other papers need to be in there too. Sorry? Chromebook? Yeah, Chromebook as well. Thank you, Alex. Thank you.
Yes, we do. No, he said no reading. He said read.
Wait there. Wait at the door for a moment. Lachlan, you can go. Yeah. Okay. Esther, you done? Lachlan, sorry, John, you can leave them all there. Thank you. That's good. Did you return your folder, Valentina? Did you return your thing? Yeah. Good, thank you. Okay, go and find a table with your partner from last lesson. Go.
Shay.
Sit with Amelia's table, yeah. Yeah, sit with Amelia, yeah. Let's go. Lily, come join back your same table, same groups, okay? Yeah. Okay. Hold on, who's your partner? Who's your partner? Partners? Okay. Sophia O is away, isn't she? Cool. And Sophia L as well. Perfect. All right. Okay. First thing I want everyone to do is I'm going to come around with a little piece of paper. There were two questions that came up last week that I want us to go back over and look at. The first thing was Pluto. We said Pluto was a dwarf planet, and we said it's a dwarf planet because
He's too small and far from the sun.
you say it's too small. Is it? Okay. Well, I've looked at it. Yeah. Okay, good. So we said it was too small. So to work out what makes it too small, we need to actually look up the diameter and find out what is the diameter of Pluto. Not yet. What was the diameter of some of the other planets that you found out? Who can remember what they were? Yeah. Name one planet and what its diameter was, roughly. Oh yeah, that's what it was. The paper was. How big is it actually in real life? What was its kilometers? Yeah, what was Earth? 12,000. Yeah. 700. About there. Excellent. Good. So that was Earth. What was? Who remembers what Mercury was? Yeah.
4,000.
Yeah, 4,800. Very good. Anyone know any other planets? Roughly? Yeah.
I know that Jupiter was like 100,020 something.
Well, that was Saturn was 120,000. Jupiter was 140,000 something. Yeah, good.
I think one of them were 10,000.
Venus was very close to Earth, both 12,000. What I want us to do is, if we know Mercury is, what's Mercury, the largest or smallest planet? Smallest, and we know Mercury's diameter was 4,800, then we know that the diameter of Pluto must be what? Or less than 4,800. So what I want us to do now is, I'm going to come around with a sticky note. On the sticky note, I want you to write your prediction. How many kilometers do you think Pluto's diameter is? I want to see who's closest, just by guessing. Don't look it up. And then the second question is, last week, someone was saying about how often are all the planets lined up in a perfect line. Do we remember talking about that? Someone said that, and we all had a different guess. How long or how often do they all perfectly line up in a row? I want you to write down your guess. How often are they all lined up perfectly in one line, all 8 planets? Okay, talk to your partner and I'll bring around the sticky notes to write your prediction. Sorry, do you have any spare sticky notes? No? That's all right. Something. Can't find my others. In your box? That's okay. Stationary. Oh, wait, everyone's okay. Okay. Are there any sticky notes in the caddies? In there, stationary caddies? No, share it in your group. So one, your guess per partner. Yes. Oh, perfect. That's what I was after. Very good. Excellent. No, they're not very good. Okay. So write down your guess, your prediction. How many kilometers is the diameter of Pluto? And how often are all the planets aligned? What do you think?
Can we search up the difference of Pluto at the end?
Yeah, we will. In a moment. I just want you to write what you think it is first. What do you think it is? What do you think the diameter is? 3,000? Okay, good. And how often do you think they're all lined up in a line? Every 12 years? Okay. What do you reckon? You reckon every 7, do you? What'd you guess?
3,208.
Did you look it up? Okay, just wondering. Once in 1,000 years, okay. Now, what's the diameter of Pluto? Where's your guess of the diameter of Pluto? No. I want you to do both. Yeah, both questions. Predict both. Like, how often do all the planets line up perfectly in line? Because they're always going round the sun. How many? Yeah, how many?
Pluto is roughly the size of the moon.
Is it?
Yeah.
Okay. Do you know the diameter of the moon? Oh, okay.
But it's roughly.
Okay, cool.
It is.
That's what I'm asking you. Okay. Shh. Turn around, look this way. Okay, I'm going to ask you, each group needs to tell me their prediction on how long the diameter of Pluto is in kilometres. We'll go around. Lily, what's your guess? Prediction? Good. Just over 2,000. Michaela, your group? What was the diameter guess or prediction? Just 2,000 even. Ooh, similar. Yeah. Okay.
2,525.
We're all around 2,000. Okay, good. 3,250.
2,346.
Okay.
2,282.
All right. Yes.
1,200.
Okay. In a moment, we're going to open our Chromebooks and we're going to find the answer. You're going to write the answer. Not yet. On the sticky note. Before we do that, what's our prediction on how often the planets are aligned? Because you're going to research that as well. How often?
About 100 to 110 years.
Okay, every 100 to 110 years. Yep. 70 years. Every 45 years. 50 years. 85 years. 5 years. Girls? Every 2,000 years. All right, let's go find the answer to all those questions and write them down. Don't change it. Just wait and see what it is. What's that?
2,346.6
What did you guess?
kilometres.
2,346.
Ooh, that's so close. That was good. Very good prediction. What did you guess? Close. 300.
39.6 years.
Hold on. Every 39 years, Mars, the 3 planets will line up. The chance, keep going. The chance that Mars, Jupiter, Saturn, Uranus, and Neptune will all be lined up will be how many years? Keep reading.
100 years.
No, keep reading.
On any given passes 1 raised to
What was this?